Yo, mathletes, welcome back. We're going to check out some slope-intercept form. So, grab your wits and let's get rolling. At the top of your notes, you can put this guy, 2-3 slope-intercept form of linear equations. And hopefully you have one of these sheets. It has this, it has this, it has this, a few things on it, a note taker. Cool? If you don't, not a problem, but you can kind of follow along and annotate as you go in your notebooks. So we looked at change yesterday. We looked at how things rise and run and move from one point to the other. But patterns have to start somewhere. So what I want to look at today is start and change. I want you to figure out where the pattern starts, how the pattern changes, and then graph it. So here's an example. I'll do this one first and maybe follow along with me, and then the other two you try on your own in a second. This is a figure. It's a shape made of matchsticks, right? And this one has some matchsticks, and this one adds this square, so it adds some matchsticks and adds some more. So what we want to figure out is where, well, just how many are here, how many are here, how many are here, how does it change, and where does it start at 0? And I'll kind of talk about that. Let's just look at this first. This is 1, 2, 3, 4, 5, 6. So this has 6 matchsticks. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9. It says 9 matchsticks. It says 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. It says 12 matchsticks. So how do you think it goes? What's the jump from here to here and the jump from here to here? It's got to be the same. You've got to be doing the same thing each time. Well, this is adding 3 each time, right? Adding 3. Great. So how does it change? Well, it increases by 3 each time, yeah? And this first one starts at 6. So this is where we start. Starts at 6, right? And how does it change? It goes up by 3, right? So our first figure, let me back up. Our first figure would be figure number 1. Here, figure number 1. That starts at 6. 1, 2, 3, 4, 5, 6. So this we could represent as figure number 1, comma, it's got 6 matches. Right? This we could represent as figure number 2, it's got 9 matches. This we could represent as figure number 3, it's got 12 matches. You want to do the click? So here's figure number 1, it's got 6 matches. Here's figure number 2, it has 9 matches. Figure number 3 has 12 matches, right? If you look at that with your nerd goggles on, which are permanently affixed to many of your heads, it makes a really nice line, right? It makes a straight line, and that shouldn't be too surprising. There's the line, because we're talking about linear equations. So what we want to know is, great, this starts, the first figure is at 6 matchsticks, but where does it start at like the 0th figure? Like if you went 1 this way, and I know if we went 1 this way, you'd have 12 and 3 more. You'd have, the next one would have 15 matchsticks. So the 4th figure would have 15 matchsticks, and that's right on our line. If we worked backwards and said, okay, what about the previous one, the 0th figure? It's just a name, the 0th figure. You'd have subtracted 3, and so the 0th figure should have 3 matchsticks. Now, I think it would just look like a triangle like that, right? We'd subtract these 3, because in each one of these we add 3 more to the base, add 3 more to the base. So the previous one we'd subtract these 3, and we'd just have these. And so I think the 0th figure would only have 3 matches in there. So the 0th figure would only have 3 matches, and that makes sense. It's like, because that's right on our line, right there. So we can write a description of this. So where does it start? 3. How does it change? It adds 3 every time we go over 1, every time we add a figure number, right? So maybe let's call that x, every time we move over 1 on the x. So the equation for this, if you want to know how many matchsticks, is, well, we started at 3, and we added 3 matches every time you went over 1 on the x. Yeah. Now you might be used to this as like y equals 3 plus 3x. Or in the future, we're going to rearrange it so it says y equals 3x plus 3. Right? But right now I want you to be able to see basically this. Right? Take that idea and try it with the duckies. A group of ducks is called a raft if they're swimming. If they're in the air, they're a flock. But what I'd like you to think about is this is raft number 1, this is raft number 2, raft number 3. I'd like you to think about how it changes from here to here and here to here. Think about what the next one might be, how many ducks in the next raft, right? And think about how many ducks in the previous raft, right, in this raft. If you can, build me an equation and maybe try to graph it from those ordered pairs that we were looking at. Try that, go. Okay, so this raft 1 has 1, 2, 3, 4, 5. This has 5 ducks. So the first raft has 5 ducks. That's an ordered pair. The second raft has 8, 9, 10, 11 ducks, right? The third raft has what, 15, 16, 17. So the third raft has 17 ducks. So it looks to me like every time we go over 1, we're going up from 5 to 11. That's an increase of 6. And here from 11 to 17, also an increase of 6. So it looks to me like we'd go from here to here, you have an increase of 6. You have 17, 18, 19, 20, 21, 22, 23. So it looks to me like this would have 23 ducks for the R4, the fourth raft. So I think your next one would be 4 ducks and 23. Sorry, the fourth raft would have 23 ducks. And the previous one, since we're removing we're going backwards on the rafts, right? We're going from the first raft to the 0th raft. Instead of adding 6, we'd go backwards and we'd subtract 6, right? I know I put a plus 6, but it's because we have some here. And so I think what this would be is you'd have -1 ducks here, because you'd say this is 5, you'd subtract 6, you'd say, like, we went from 11 ducks backwards to 5 ducks by saying 11 minus this change. That gave us 5, right? We're going to do the same thing here. We're going to say, hey, I started with 5. How did I get there? Well, I added 6. So to get back to where we subtract 6. That leaves us with -1. Now I don't know how do you show -1 ducks? I don't know. Do you like flip them over and make them look evil, or make them look grumpy? But we have -1 ducks, so I think that this would be on the 0th raft. You'd have -1. And that makes sense because every time we go over from 0 to 1, we go up 6 units here. We go from 1 to 2, up 6 units. 2 to 3, up 6 units on the duck number. 3 to 4, up 6 units, right? So we're playing that game. All right. Let's put that back. So it looks like, how does it change? Well, we're adding 6 ducks every time we go over. Where does it start? Well, it starts at 0, right? Like the 0th is where it starts. That happens at -1. There's -1 ducks there. So the equation is, well, how many ducks? The number of ducks equals, you got to start at -1, and you add 6 every time we go over 1 on the x. Or you can think about it as y equals -1 plus 6x. Or if you're a true nerd, you swap it around and make it y equals, 6 is positive, keep it positive. 1 is negative, keep it negative. This is where, that's it. That's the equation for it. So if we were to graph this is 1, 5. First raft, 5 ducks. Second raft, 11 ducks. Third raft, 17 ducks, right, etc. And if we take a nice straight line that's kind of sharp, and let's make it something visible, and we try to run it from here to here, if you hit all those correctly, this seems legit. It seems like you would hit at 0, it seems like you'd hit here. And so I like this point. Seems weird because we're talking about ducks, but I think it's good. Right, 0, 1, -1. So this is our line that describes the change in ducks, and this is the equation that describes the line. And we build it by thinking about where it starts and how it changes. Let's try that one more time, right, with this dwindling blocks. Okay, I'd like you to think about where it's. This is pile 1. Figure out maybe what pile 4 is going to be. Figure out what pile 0 is going to be. Think about how it changes and where does it start at 0. Go. All right, so pile 1 has 8, 9, 10, 8, 9, 10, 11, 12, 13, 14. So this first pile has 14 blocks. 6, 10, this has 10. So pile 2 has 10 blocks. Pile 3 has 4, 5, 6 blocks. So going from here to here and here to here, it looks like we're subtracting 4 each time, subtracting 4 each time. So the next pile, I think, would have the fourth pile, it looks like would have 2 blocks because we're removing 4, right? We've removed 1, 2, 3, 4. We've gotten rid of these 4, and now this leftover looks like this. And if we get rid of 1, 2, 3, 4, these, it looks like this. And if we get rid of these 1, 2, 3, 4, we're just left with 1, 2. So that's my guess. Right? Great. So therefore, if you were to work backwards, what's the 0th? Where does it start? Well, you had to subtract 4 from something to get 14. So if you add 4 back, you should have 18 blocks. So I think this is going to be 0, 18. All right, so I don't know what it'll look like. This same sort of thing with extra blocks on top, right? And you get the picture. 18 blocks, right? So where does it start at 0? Well, it starts at 18, right? So at 0, it starts up here. Ooh, I can't see from my. So it starts here. There's 18. Ping. How does it change? Well, it goes down by 4 every time it goes over 1 on the x, right? So you go down 4 and over 1. So let's see. The next one is 1, 14. So 1 over and 14 up. Next one is 2, 10. 3, 6, and 4, 2. And so let's make our nice straight line and make sure it fits nicely. Let's go blue, like that, and it looks like it fits nicely. Great. Okay. So our equation, if you wrote this, is I know that it starts at 18. Well, let's redo that. I know that the number of blocks is equal to, well, if we start at 18 and then we subtract 4 blocks every time you go over 1 on the x, right? And hopefully that makes sense. Like if you start with 18 blocks and you want to go over 2 spaces on the x, you subtract this and this. So you subtract -4 times those 2 spaces, right? So then we go from 18 down by -4 times 2, which is -8, and that's exactly where we expect to find it. So I like our equation. So 18 minus 4 every x. And if you wanted to switch that around so it looks like a real equation, it's -4x because the negative is stuck to the 4, and the 18, what's in front of the 18? Nothing, which means it's positive. So that's our equation. All right. So what I'd like you to have in your notes is that slope-intercept form looks like this. It starts here. We're going to call that C. And it changes like this. We're going to call that M every time we move over 1 unit, x. You'll notice that this slope, this M, is the change. It's the slope. Here, the slope was rise over run. So this was rise over run. It was 1, 2, 3, 4, 5, 6. 6 units up, 1 over. Oh yeah, that's our slope. Same thing here. This was -4. Between this point and this point it goes down 1, 2, 3, 4, 5, 6, 7, 8, and it runs over 1, 2, right? So its slope from yesterday that we learned was rise over run, which is -4, which is exactly what we see right there. Cool? So this is where we start on the y-axis. This is how it changes. It's its slope. And this is what every time we move over 1x. Cool. If you'd like to move those things around, sometimes you see it like this with the slope and the x first and the c. And it's the c and the y-intercept and the slope. Those things are what we need to replace. So if we're trying to show an equation for this line, we figure out where it hits the y-intercept. Oh, hey, here at 0, 1. That's what this is about. And then we find its slope. Well, it rises 2 and it runs 1, so its slope is 2 over 1, which is simplified to just 2, and that's this part. Cool? All right, trial by fire. Figure out the equation for that and write it in slope-intercept form. Pause me until you got it. Go. All right, so slope-intercept form looks like y equals where it starts plus how it changes times x. It looks like it starts here on the y-intercept at 2, so we start at 2 and we go down 1 unit and over 1, 2. So we go down, its slope is rise -1 over 2. Or if you went from this point to this point, it goes down 2 and over 4, right? Oh, down 2 and over 4, which is this same thing, right? So it doesn't matter how you do it, but the slope is, it rises -1 and runs 2 every time you go over on the x. If you're a true math nerd, you clean that up to say y is -1/2 x plus 2. Heavy, but not too heavy for you. We'll check this out more when I see you tomorrow, and we'll go from there. Cool? Carry on.